And good evening, everybody, and welcome back to the page, Astronomy by the Bay. It's Chris Kerwin here. I've got Paul Owen up in Hampton at the moment, and right now we're going to be, well, I'll show myself here for a few minutes. We've got a few things to bring up here on our program tonight. We've had some technical difficulties again, as we normally do after 2 or 3 nights. We thought we were all through them by this point, guys, but
we're just learning new ones.
We're learning new ones. Yeah, that's it. Oh well, it's always a challenge when you're off live stacking and live viewing of objects. So I had issues with my camera here tonight, my own camera on my laptop. Anyway, we got by all that, and Paul was getting some issues with Venus, but and we'll say hello to Peter from sunny Toronto. Welcome, Peter. We're getting some cloud cover here shortly, but we're hoping to get ourselves at least an hour show in. So Mike, right now, Mike has gone out to his observatory to retarget something else. Paul's going to offer us a view of Venus here first of all. We've got a little bit of talk about some star parties that we have coming up. I just want to mention a little bit about those, and I'll show some photos from some previous years, what the star party is all about for us. We have a Mike Guyver segment as well that Mike is going to discuss a little bit about webcams and how webcams can become useful in the astronomy hobby for purposes other than just what you would normally think a webcam would do for you. And other than that, we've got Rosanna's fun facts coming up as well, I think. we're not quite sure.
We get something.
We get something coming up. Yeah, we're not sure yet exactly.
As long as Mike goes first, we're good.
So yeah, we're gonna give you part of an evening anyway. Yeah, there's Mike. Hey, Mike.
We're in business.
We're back.
I just gotta try something here.
Okay.
How do I do this?
I'm not sure. I can't see it from here. Let's see who's joined on. They joined at a decline. Welcome. Hey guys, hope things are going well tonight. Missed you last week. That's okay. We're still here. Hey, Emil. Welcome. And Sighorn. Hi all. Hey, it's 8:08. Is this live or was it taped prior? It's actually live, Irene. We're just a little bit late coming to you but that's what happens with live feeds. We don't always get what we want to start out with. So but we are here live with you now, and we're going to be on for an hour. So whatever it takes us to get through this. Chris, can I send you some photos of my almost full moon tonight? And if yes, where should I send it? So Irene, I'm not sure if I could get that photo up tonight on tonight's show, but you can certainly send it to Sunday Night Astronomy Show at gmail.com. It's all one word, Sunday Night Astronomy Show at gmail.com. Or you could send it to my Facebook page, Astronomy by the Bay, if you like, that way as well. And I can pick it up there. If I can possibly get it up on the screen tonight, I will. But if you want, yeah, maybe send it through to my Facebook page as an inbox message, and I'll see if I can get it up here, and hopefully we can display that tonight too. Good evening, Robert, and hello, Treaty. Welcome, everybody. So we're just we're a little bit behind right now because we had some technical difficulties here getting set up, but we're ready to go ahead with what we've got, I guess. Right, guys?
Sure.
Oh yeah.
Sure we are. Yeah, this is the fun part. Okay, so first up, I guess, Paul, you're going to offer a view of Venus here for us? Or?
Yes, okay. Let me just see if I can't share my screen.
Your screen.
And there you be. You should be able to see it now.
There she is.
Okay, so I'll just explain a little bit of what's going on here. When you try to live stack with this one, it wants to grab 3 stars, and there is no stars around that I could get because of the focal length that I'm using. So I decided to go mono instead of color, but it doesn't really matter because it's what we want to show was the actual phase that Venus is in. So we're able to catch the phase, which is nice, and I'll let Chris talk about all that.
Okay. You caught me off guard. I thought you were going to talk a little longer than that.
Oh, well, okay.
That's okay. No.
You wait. I'm going to catch you right off guard because I got a different target altogether.
Oh, boy.
Just before Chris talks
Wonderful.
about all that. Well, actually, I can tell a little bit about it if you like.
Maybe, if you, for a minute or two. I'm just working on something else here at the same time. So.
Yeah, okay. So basically, what I've got here was actually Mike was going to show Venus, and then my telescope wasn't in focus, so I decided to go out there and find something bright enough I could focus on. And I just happened to get a longer focal length on my scope than Mike did. So he said, well, you show Venus. So here we are. But in any event, the reason I wanted to show we talked about showing this was because Mike's scope wasn't able to show the phase. And here we can see the phase. So for those out there who've never really looked at Venus before through a telescope, you just kind of look up in the sky and it's that really beautiful, bright, glowing, looks like a big star. It's actually a planet, and Venus phases just like our moon does. And so that, so just like our moon has different phases, so from our perspective, so does Venus. And right now, it looks like Venus is at, I would say, about first quarter.
It is. I think so. Yep.
First quarter, yeah.
Very
So,
close.
so if I had a little bit more focal length and a little more time to set this up, we might be able to see some form of color there. But the main thing here was to be able to actually see the disk and see that it does that Venus in fact does phase. So you can look at Venus in a lot of ways like the moon, certainly not detail, but you can watch the various phases of Venus, and it's very bright and very close right now. So this is a really, really good opportunity to see Venus, even through a small telescope. If you can get it up there, like with a 400 to 600 millimeter focal length, you should be able to get you'd be able to see that and actually see the phasing of the planet.
So yeah, Venus is of course it's a second planet from the sun, orbiting the sun every 225 days, and it's the longest rotation of any of the planets out there. It's also, of course, the third brightest object in our sky behind the sun and the moon. And it's making a very steep line with the ecliptic there in our evening sky. So in our evening sky, Venus is quite high. In our morning sky, the planets are quite low. That's what happens at this time of year. They flip around in autumn so that the planets are higher in autumn and they're lower in the evening sky. So we got Venus up nice and high right now. Lots of time to view Venus through binoculars. It'll look just like this pretty well with a little crescent phase. Well, you might get a bit of the crescent, the shape of it there through binoculars. Better, of course, through a telescope. But we can see that that Venus is in a phase right now, and the two inner planets, Mercury and Venus, they're inferior planets, so they both give us phases just like our moon does. It takes again 225 days for Venus to rotate around the sun, but it has also the longest rotation period of any of the planets. It actually takes Venus 243 days to rotate once on its own axis. So that means that a day on Venus is actually longer than a year on Venus, which is kind of odd.
Yeah.
It also rotates in the opposite direction of all the other planets. So on Venus, the sun would actually rise in the west and set in the east. And it's the third brightest object in the sky, as I mentioned, bright enough to cast shadows at night. You can see Venus reflecting light onto the bay and stuff too, very easily. Can be seen also with the naked eye in daylight if you know exactly where to look. So there are certain times when Venus is close to other objects in the daytime sky, and if you know exactly where to look, Venus is bright enough to be able to pick up through binoculars or a small telescope. Kurt, our member of the St. John Club, is pretty good at that actually. He's usually the one who can pick out an object before anybody else can see it at any star party event for sure. Oh, there's my phone beeping away. It never really appears to venture too far from the sun, and as an inferior planet, it shows phases like our moon. Venus is sometimes called Earth's sister planet due to its similar size, and it's named after the Roman god of beauty, but that's about where the beauty kind of ends. Venus has the densest atmosphere of all the planets in the solar system. It's about 96% carbon dioxide. And if you were to stand on Venus, the atmospheric pressure on you would be 92 times the pressure here on Earth that you experience. About the same pressure as being 3,000 feet beneath the ocean. So you wouldn't really have much of a chance to take a walk around on Venus. Of course, you wouldn't probably want to anyway. It's mostly covered with lava. It's also by far the hottest planet in the whole solar system, with a surface temperature of about 460 degrees Celsius. And it's surrounded by a very thick layer of highly reflective clouds of sulfuric acid, so it rains sulfuric acid on Venus. And we believe that long ago it may have had water oceans at one time, but they would have vaporized due to the greenhouse effect. So sunlight gets trapped in Venus's cloud layers, and it causes the planet to heat up. And this is a talk that I do a lot when I visit schools, classrooms, that type of thing. Venus is it's a runaway greenhouse effect planet. So I try to enforce into the kids that when we're talking about our environment here on our planet and the pollution that we expel into our atmosphere, um, our oceans are warming, our planet is changing temperature. I mean, it's climate change, yes, but it's for sure that we're having quite an effect on it as well. We're probably accelerating that process. And I no, I don't try to scare them, but I show them what it likes what it looks like on Venus and what Venus's atmosphere is like and what the planet Venus is like. And I just say, we don't want to look like that someday. So leave it up to your generation to try to solve our pollution problems. Good luck, kids.
That's right.
Yeah, we made a mess of it, so you guys clean it up. You don't
You
mind.
won't put a plastic bag around it anyway.
Yeah, yeah, that's right.
Certainly not from Sobeys.
When
Yeah,
you shovel
true.
the driveway, this is what you
Yeah, that's true. So yeah, it reflects about 97% of its light back into space. That's why it's so bright when we see it in our evening sky or early evening sky or in our morning sky, I guess too. So, um, but yeah, that's the effect of the greenhouse effect that we experience with Venus. Um, we can't see through the clouds of Venus, so we have to send spacecraft to do some radar mapping. So we did that, and we actually stripped away the clouds, and we found out that Venus is actually covered with smooth volcanic plains. Venus has mountains as well, with its highest rising 11 kilometers above the surface of Venus. And the surface has very few impact craters, indicating that its surface is very young, perhaps only 3 to 600 million years old. I guess that's probably a lot of that is because of the lava that's flowing on its surface. Um, Venus also has many volcanoes, over 160 of them are more than 100 kilometers across. And I guess the Russians had sent some spacecraft up there, the Venera series of spacecraft that had landed on Venus, and they were built like a tank, basically. But they didn't last very long in the environment. There's only a few pictures that were actually released of the planet Venus from the surface. And I didn't actually get one loaded here tonight, but maybe I'll do that on a future show. Right now, we're showing Venus at minus 4.2 brightness wise. So that's again, it's the third brightest object in the sky behind the sun and the moon. Its range from us is 0.83 astronomical units, so it's 8/10 of the way to the sun from us. It's inferior conjunction, so that means when Venus is going to pass behind the sun from our point of view on June the 3rd of this year. So we have it fairly high in our sky right now. Superior conjunction, I'm sorry, that's inferior conjunction. That's going to be between us and the sun on June the 3rd. Of course, we rotate counterclockwise. All of us go around counterclockwise, so we're coming up to inferior conjunction. And then let me have a look at the time here, March the 26th of 2021, it'll be at superior conjunction. So it'll be on the opposite side of the sun from us on March the 26th of 2021. But the date that's coming up that kind of is great for us is on March the 24th of 2020 is when it reaches its maximum eastern elongation. So that means it's going to be the farthest east in the sky once the sun sets that we can see it. So that means it's going to be up a longer period of time through our evening as well, simply because it'll take longer for it to set, I guess is what I'm trying to say. And where the ecliptic line, that line that the path the planets and the moon and the sun all take, is very steep again at this time of year in our evening sky. So that means Venus is going to be very high and it's going to stay up for quite a while. Like it's not going to set very early. So I think trying to find sun or set times. I'm not sure if they list set times here on. I'm on a website called heavensabove.com. And yeah, it sets at March the 8th tonight. It doesn't set until 11:30. If I move that ahead till April, for instance, and update the time for that, it shows that in April it sets at midnight. and it rises at 8 in the morning. So it's up all day. So again, you could find it if you knew where to look for it. Perihelion for Venus, October the 30th of 2020. So that's when we'll be at the closest. It'll be at its closest approach to us on October the 30th. So Venus, a nice target. It introduces phases like this, just like our moon does again, and that's because of sunlight reflecting off it, of course, from our point of view, looking back at Venus. It's the same reason why we see the moon at phases when we do throughout the month. All depends on its placement in relation to us in the sky.
Something to mention too, Chris, about that, if anybody's ever looks through a telescope at something like that, excuse me, pardon me, like this, and they see a lot of movement, like we see on this particular live shot, that movement is basically the atmosphere that we're trying to look through to see this target. So you're going to get fleeting moments where it's clear and other moments where it's all distorted. So depending on the night and how good the seeing conditions are, if you got really, really good seeing conditions, that'll stay pretty steady, and then you'd have a lot better time to try to observe Venus and its and whatever details that you're going to try to tease out of it. And that goes for basically all the planets. But as they get really small, and Venus is a very small planet because we're going through a telescope at 1800 millimeters. So it's not an extremely long telescope for planetary, but it's longer than a standard Newtonian or something that most people would have. But if you put a Barlow lens in your telescope and blow it up, you may see these distortions. But don't be afraid that it's anything wrong with the optics or anything like that. It's just generally the conditions that you have to look through.
That's great. Thanks, Paul. I wanted to first of all stop and give a shout out to a couple of people here. Mike and Paul, if you would join me to give a shout out to my brother Danny, who tunes in every week.
Hey,
Danny, he tunes in faithfully every week to us, and he's always asked me if I could say hello to them on the show. So here he's got the shout out. So Danny, welcome to the show, and I'd also like to say hello to my son Paul out in Winnipeg right now, who's also tuned in. Him and Catherine are in Winnipeg right now enjoying the show, he says. So he's asked a question here about webcams. He's asking what is the best phone or webcam for taking still shots. So we're going to get to that, Paul, in just a little bit once we get onto the webcam topic a little bit. But I will keep your comment here, son. Hope he's not trolling me tonight. Because he knows how to do it. He knows how to do it. Irene, Paul, that distortion happens with my camera and the moon at times. Yes, it does, Irene. So that's just basically sunlight reflecting back through the thicker part of the atmosphere, of course. So all the light that we're seeing here from Venus, of course, is just reflected sunlight. The sunlight has to go and hit Venus, and then it has to bounce back at us. So reflected sunlight, it has a more difficult time getting through the atmosphere than pinpoint starlight, I guess. So stars generate their own light, of course. So when we're looking at light from Saturn or from Venus or any objects that are down closer to the horizon, we're going to see a lot more of this distortion. All this depends on what's happening in the air at that time too. If we've got a lot of moisture content in the air and ice crystals or things like that, that's going to affect our view as well. That's a great view there, Paul.
Yes. Yes, it looks good.
Yeah, it's a lot better than what I have.
So I already have one question there too, Chris.
Irene asked, is it possible we can tell the moon is larger tonight than usual? Yes, Irene, it is actually larger tonight because we're heading towards what we call supermoon. Bum, bum, bum. We'll have to get a tune for that too.
Yeah.
So supermoon is just a term that was coined by someone who described the fact that the moon is at what we call perigee. Within 1 day of perigee, basically, or 24 hours of perigee. So perigee, because the moon orbits us in an elliptical path, there are times when the moon is closer to us than it is at other times. So when it's closer to us, we call it a perigean moon. When it's farther away, we call it an apogean moon. So when the moon is close to us at full moon and it's a perigean moon, we call that a supermoon. Now we're going to actually be at our full moon phase on 10th actually. At I think it's 2:40 in the afternoon, something like that, when we actually are at 100% full moon. But that's at we're going to be at about 357,000 kilometers away from the moon at that time. Today we're about 359,000 kilometers away, so not much difference, but some. But because the supermoon comes tomorrow night, um, it rises tomorrow night around 7:30 local time here in Atlantic Canada. We're going to see the moon appear about 30% brighter and about 14% larger. Supermoon, Emil says, yeah.
Ow.
Yeah. So, uh,
Werewolves of
yeah.
London.
The bigger effect is really something called the moon illusion. I wish I had brought those slides up tonight too. I should have had that ready. Um, Look, you go out 1 month and you'll take a look at the moon and it'll be a normal moon, and then the next month they'll say it's a supermoon. Now, I don't know if I could remember exactly how big the moon was, if it was 13% bigger this month than it was last month. I can't even remember what I had for breakfast yesterday, so let alone what the moon looked like last month, at that same time. So maybe if you stood at the exactly same spot and you watched the moon rise and you went back the next month, which you usually don't get two clear nights on the same day anyway. Um, you might be able to notice that it does appear larger, but that's really a lot of that is called the moon illusion. That happens every month anyway with the full moon. Our brains picture the moon larger because there are objects around it that we can compare to, and it appears much closer to us um, for different reasons. If you had a set of train tracks and they went off in the distance, and you had a large ball at the front end of the train tracks and it's the same size ball at the other end, it would appear larger at the other end. Our brain plays those tricks on us, and that's the moon illusion. There are more slides that I can get into about that maybe at a later time, maybe on the next supermoon when we're still doing broadcasts. But basically, is if you see the moon at the horizon like that, it does appear big. But if you look at the moon a couple hours later and it's up in the sky, our brain doesn't have anything to compare it against. There's nothing around it to compare it against. It's just the sky, open sky, so it appears a lot smaller, although it's the same distance away, maybe a few 100 kilometers difference, but not much. Not enough really to show that it's huge at the horizon. So, but if you're out in any doubt about that, just next time you're out looking at the super moon popping up or a full moon coming up over the horizon, make a fist and punch a small hole down through your fist, and then hold that up to your eyeball and look at the moon that way. So what you're doing is canceling out the effect of all the other things that are around you, uh, keeping you from looking at the moon directly. And if you look at the moon through a hole in your fist, you'll find that the moon appears very tiny, back to its normal size again. So yes, Irene, to get back to your question, the moon would appear a bit larger tonight. Tomorrow night would be a better night, but locally here we're going to have cloud and showers, I think, or snow or something, hurricane or I don't know, typhoon or something coming through.
Okay, I'm going to switch off of Venus so that you guys can move on to something else. That sound. So you just give me a second
Thanks,
here,
Paul.
and I'll figure out how to do what I should be doing. Stop.
Okay. So are you gonna?
There we go.
Perfect, thank you. So are you gonna hop to the moon?
No, actually, I might. Let's just you guys continue, and I'll see what I can find.
Okay, perfect. So Mike,
Hello.
how you doing?
Hey. Good.
Welcome back.
Thank you. Nothing a hammer couldn't fix.
Nothing. And that's why you're Mike Iver.
I did spin around and get my scope on a different object. It's with the moon coming up and fading out some of the sky, but I was actually quite impressed. I got the M44, the Beehive cluster.
Oh, nice. Okay.
And it's coming up pretty good. Just before I share the screen, if I may, I'd like to turn around and say, throw out there a happy birthday to my granddaughter yesterday. She turned 3 years old. Happy birthday, Annabelle.
Happy birthday, Annabelle.
Best granddaughter in the world, but because you're the only one I got.
There you go. Nice.
So let me throw
Happy
my
birthday,
screen
Annabelle.
up here. And we should be sharing the Beehive cluster.
We are.
Like I said, it might be a little bit faded out because the moon's fairly close to it. And that side of the sky tonight's quite bright, but you can definitely make out the individual stars and all the double stars that are inside it. So You got a speech on that one?
Oh, you did have, but not off the top of my head. Just a sec, I'll pull it up. uh, okay, so there's approximately about 1,000 stars in the Beehive cluster. Amazing. M44, I guess we call that.
Tis, yep.
Tis M44.
That's how I found it in the hand pad, either way.
So it's in Cancer, the zodiac sign of Cancer, the crab. I'll just read a little bit here. It says, although it's one of the 12 constellations of the zodiac, Cancer the crab is so faint that you'd likely never notice it except for the lovely star cluster in its midst. The cluster is commonly known as the Beehive, or M44. And astronomers know it as NGC 2632. An older name is Praecip, or a manger, or crib in Latin. The Beehive is a wonderful swarm of stars glimpsed with the eye in a dark location and easily found in binoculars. Its size is 1.5 degrees, or about 3 full moon diameters, and although the eye cannot detect them, it contains about 1,000 stars. So the best way to find the Beehive cluster is keep an eye out for the star Regulus and the Gemini stars Castor and Pollux, the young guide stars to the Beehive cluster. The Beehive cluster is about halfway between Regulus and the Castor and Pollux pair. So Castor and Pollux are the two stars that make up Gemini the Twins, the two heads of Gemini the Twins, and Regulus is actually the belly star, or I guess the front paws star of Leo the Lion. So in March, look in the east after dark, you'll probably see Regulus, the brightest star in the constellation of Leo, rather close to the eastern horizon. It is close to the eastern horizon now. In another few weeks, it's going to be a lot higher. We're going to get some nice galaxies. Then the bright stars Castor and Pollux are in the constellation of Gemini. They'll catch your eye up even higher in the sky. As the months pass, the Beehive will climb higher in the evening sky, and it disappears from the western evening sky in late June. And then it returns to the eastern morning sky starting again around late August. You'd think that an object with so many names, NGC 2632, M44, Praecip, Beehive, would be bright. But the Beehive star cluster isn't bright. Only in dark country skies can you see this faint fuzzy object with the unaided eye. However, binoculars magically transform this smudge of light into a glittery swarm of stars. There are approximately 1,000 stars in the beautiful Beehive cluster, which is an open cluster of stars in our galaxy. So that's a cluster of stars that are loosely bound together by gravity. We're going to get into some what we call globular clusters a little bit later on in some of our future shows, which are going to show you stars that are a lot more tighter bound together and bigger balls of stars in the grouping. Open clusters are stars that are gravitationally bound and are created out of the same star-forming nebula, such as the stars that are in the Orion Nebula. The Beehive is one of the nearest open star clusters to our Sun and Earth, and it has a larger population of stars than most of the nearby clusters. The Beehive open cluster's distance is estimated to be between 520 and 610 light years from our solar system. If you use binoculars to see the Beehive, the brightest star you're going to see is called 42 Cancri. In 2012, 2 planets were found in the Beehive by the Kepler Space Observatory. They orbit 2 different stars and have been designated with the names anyway. Both of these planets are hot Jupiters. That means that they're massive gas giant planets, in both cases orbiting very close to their stars. These 2 were the first planets detected orbiting stars like our own Sun that were situated in an open star cluster. Since their discovery, Kepler has found 4 more exoplanets orbiting stars in the Beehive. And we believe there's at least 1 planet orbiting every star in our galaxy at least. Galileo had the first telescope view of the Beehive back in 1609. With his paper tube and 2 pieces of glass, he was able to detect 40 stars. Unreal. Was that a toilet paper tube, I wonder, or a paper towel roll tube?
They weren't running out. They didn't have the coronavirus.
Wah, wah, wah. Around 1769, Charles Messier. Oh, Hello.
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 You there? What
This
happened
is me.
there?
Is that you?
Blip. Okay. Had a power bump. Around 1769, Charles Messier added the cluster to his famous catalog of nebulous objects, hence the designation M44, the 44th object in Messier's catalog. And I just want to be sure that I'm just checking on our live feed. Heck, we're still live. Okay, good. I got about 15 screens open here. The Beehive cluster was known as a manger in Greek and Roman mythology. You might notice the two bright stars on either side of the cluster with your binoculars, or you might see them with the unaided eye in dark skies. These two stars are Asellus borealis and Asellus australis. Say that 5 times fast.
Yeah, really.
Yeah.
In sky lore, they represent the donkeys that the Dionys and Silenus rode into battle against the Titans. Oh, imagine that. There. That's about all I have for the Beehive cluster.
That's more than I had.
Well, Beehive is
more than I had too.
I wasn't even surprised to get it with the moon so close to it. So
Yeah.
Yeah. Well, speaking of the moon, I have it.
Oh, you do? Perfect.
I'll stop
Okay.
sharing.
Yeah.
She's all yours, Paul.
I'm just getting trying to get it so like it's purdy,
Birdie.
and you can see some things on it.
So
And yeah, it's looking good. I think it's okay. So whenever you want it, you just tell me.
Okay. Just looking. Emil, hang on. I'm just looking for comments here too, guys. So
Sure.
let me read through here what we got going on. I'm not keeping up to the comments. I'm kind of watching 3 other screens here. So.
All right.
Paul Arthur's not trolling tonight. If I were trolling, I'd ask, what's the best webcam to take pictures of Uranus? You know what he said instead of Uranus. Thanks, Paul. Appreciate that.
Yeah.
Emil says it's a fine binocular object. It is. Yeah. It appears as a fuzzy patch to the unaided eye. No fitting that in a zoom 2000 millimeter field of view. That's for sure. Very open cluster. How many stars classify it as a cluster? I've been asked. 2.
More than one, yeah.
two or more.
2 and 3 little beers.
There you go.
And there's 6 or 8.
That's a question for you.
That's my son there again. Yeah, not trolling, he says. Not trolling. Oh, no, I'm not trolling.
No.
Well, we've got binary star systems. We have quadruple star systems. We have quintuple, sextuplet systems. So maybe above that, I'd say that we're starting to get into clusters. If you look at some clusters are 40 stars or less even. So I'd have to say that anything up around maybe around 10 stars or more, you'd start to call a cluster. Some of the ones, if we talk about globular clusters, we're talking about 500,000 stars or more in some of these clusters that we'll be looking at later on. So hopefully that answered your question there, Paul. That's enough questions for you. Thank you very much.
There you are.
Yeah, okay. So where are we going for now? We're going to the moon.
Going to the moon. Just pretend we're in 1969
Fly
and Kennedy's still president.
Oh, so Emil says open clusters are not gravitationally bound like multiple star systems. Thanks, Emil. Not as much, I guess. Not as much. They're not bound to really as much as multiple star systems. Let's find out where you are, Paul. Here you are.
Okay.
Here, okay, got you up.
There you go. There be the moon.
There be the moon. Oh my heavens! Look at the size
Isn't
of
it?
that thing.
It's a super moon.
That's
Come
a
on.
super moon.
Look at your window. It takes up the whole window pane. That is a super moon.
Oh boy, it's gonna be one of them nights. That is actually, a super moon.
The focal length on that's 1800 millimeters, so I can't get that whole moon in that one image. I'll get it down as small as I can so we can see as much of it as we can. That's about it right there.
Wow.
That's all I can show you. But I can move around on it, so that's not an issue. So I'll push it back up, and then you can do
which one are you? What scope are you using there?
I'm using that Equinox 120 millimeter.
Okay.
It's 900 millimeter focal length, but I got a Barlow on it.
Oh, you bar loaded.
Yeah, it's bar loaded.
She's a loaded one.
Yes. So I'm just going to play around with it, and you can just chat about the moon.
What do you want to say about the moon?
I don't know.
It's round.
It's
It's a
super.
round ball. It's super. It's super tonight.
It's super tonight. Yeah.
Oh, let me get out some of my
You
notes.
can see, if you look really closely, you can see a lot of the crater stuff, even at this phase.
Hmm.
If you look at that edge, you can still see a lot of the crater activity there. So even if you're looking at a full moon, and you can certainly see more of the Maria and injector rays and all those wonderful things, but you can still, if you look around the edge at any time with the moon, you can always see some form of detail.
Yeah. No, it's a pretty picture no matter when you look at it. I remember growing up looking at the moon and seeing the moon. I'd look up, oh, look at all the bright light. But once you look at it through a telescope, it never appears the same again.
No.
It just never it now it's a celestial body. Like it's something that you want to study. It's something that you want for it to reveal parts to you. Like so it's become an astronomical body now to me. When I look up, I'm not looking at how the moon is reflecting on the water, although that's kind of nice and romantic and all that kind of thing. But I'm more looking at the fact that I'm looking at detail. What detail can I see at this particular phase of the moon? Where is it placed right now? Like how high is it in the sky, and what phase are we at, and what's being revealed? That's what I see when I see the moon now. And I think a lot of people, once they see it for themselves through the eyepiece of a telescope, they're amazed at what they can actually see for detail. And I think a lot of people that have been by the eyepiece and have come to outreach events with us and that kind of thing, that's why we always get that wow factor. This is the one here that brings out the most wow to people. I think because it's so close to us that we can actually see so much detail, and the fact that people have never really looked at the moon like this before. When you get the opportunity to give somebody their first glance of the moon through an eyepiece, there's no feeling like it. Like for me, for sure. I know you guys are the same. That when you get the opportunity to introduce the night sky or one of these celestial bodies to people, this one and Saturn, I guess, are probably the two that get the biggest wow factor. And that's what we call the wow factor, because everybody comes to the eyepiece of this wow. They can't believe the detail that we can see. And and this is why it's kind of nice to be able to offer live views like this the way we're doing it here, because there are a lot of people that can't get to the telescope. That's part of the reason why we do these, is that we know there are a lot of people that aren't able to reach us at the eyepiece. So sharing a view like this, and that's why I like to do a lot of my own live feeds on Facebook, simply because this view is can be so popular to people. They start to see it now as a celestial body in a dance with Earth.
Can I point something out?
Sure. That I'm talking too much.
That
I'm talking too much.
No, not at all. I just want to show you this because the way that the camera is turned, the orientation of this particular object, maybe you'll finally see this. So if you look, can you see my mouse going around the?
I can see your mouse, yes.
And where am I going around? America, right?
You're looking at the Sea of Crises.
Right. But now if you look, there's an eye, there's another eye, and there's a snout. This is a bear's face. And there's his head.
Come on, Paul.
You don't see that? I've been trying to show you that for so long.
Yeah.
There's the two little eyes, right? There's his nose.
I see the eyes. Yeah, I can go along with that.
And there's the head. There's the head of the bear. It's a black bear.
Okay, anybody out there in YouTube land see a black bear there? Just comment, please.
No.
Not seeing any comments yet, Paul.
All right, that's it. It's the last time I'm going to show it. It's
your thing. Yes, it is. Can you see the Tyrannosaurus Rex there, or T-Rex, or?
A sec, I'll get it so you can see it a little better.
Can you see T-Rex? No, well, not really. No, he's kind of flipped, isn't he?
He's over here, isn't he?
Well, there's a beetle on the moon, so that's the ant. There's the center of his body there, and just below it is the tail. There's.
I'll go down a little more.
No, we're not going to. No, we need probably a little bit darker to pick them out.
Oops.
Oh, that's okay. We can forget about that.
Yeah, sorry. Didn't mean to get off topic.
Yeah.
Sorry.
Well, we did. We all did. Irene says, seems to me the large crater that looks like a navel of an orange is usually more towards the bottom of the moon. Well, it is, Irene. This is
Tycho.
the view that Tycho, that's right. Tycho is about 108 million years old, I think they said. And one of the larger craters on the moon, but not the largest. But it actually shows probably the most definition. Tycho is one of the younger craters on the moon for sure, at about 108 million years old. And there's actually a central mountain peak in the center of Tycho there. Really hard to see from this point of view, but you can see the rays that are extended out there, the ejecta rays are extended out there about 1,500 kilometers in all directions. And I think it was Apollo 12 that landed, or Apollo 14 maybe, that landed at the edge of one of those crater rays, and they brought back samples of that. And that's, I guess, how they dated it, basically, by the material that was ejected out. Of course, when these meteors or these rocks of huge size hit the moon, there's nothing to slow them down. There's no atmosphere on the moon. It's a vacuum, so they release all of their energy, coming in at tremendous speeds, and they release all their energy at once during impact. So that's why these craters seem to be so big, and they are big. I mean, some of them are down to 4 kilometers deep.
Can I share my screen for a second there, Chris?
Sure, please, yeah. Paul up there, Paul. Okay, so
Well,
keep the moon in.
she was asking, the crater kind of looks like it's to the side.
Right, yeah.
And I'll show you, probably here's the reason why. If you look here, I'll throw this up. You'll see the inside of my observatory.
I'm going to
You'll
get
see
you there.
my mount, and of course, the scopes are laying sideways.
Right.
So as the scope rotates sideways, the orientation to the moon is going to look different.
Yes.
So that's probably why Tycho looks like it's up, to the upper right-hand side as opposed to down to the bottom. It's just the orientation of the scopes.
Yeah, that's more the reason.
So there you go.
Same in my reflector telescope, it would be flipped upside down, right? So, thanks, Mike.
Yeah.
Of course, the moon is the Earth's only natural satellite. It's about the 5th largest satellite in the solar system, and it's the 2nd densest, next to Jupiter's moon Io. It's believed that the moon was formed about 4.1 billion years ago, not long after the formation of the Earth. The most widely accepted theory for the moon's formation is that a body about the size of Mars, which we call Theia, collided with our Earth in our early days, and it almost destroyed us. But the material from the collision orbited the Earth and eventually coalesced to form our moon. And the reason we understand that this is what happened is because we brought back over 805 pounds of rocks from the moon on our Apollo missions between 1969 and 1972. The 12 American astronauts that walked on the moon brought back those samples, and they were all Americans and they were all males. And should that have happened? No, absolutely not. But at the time, in those times, you had to be a test pilot to be an astronaut, and you could not be a woman and be a test pilot. So that's all changed, of course. And now we have women that are on the space station regularly, and we're going to actually put our first female astronaut is going to be on the moon in 2024 if everything goes the way that Mr. Trump would like to see it go. They'll be walking on the moon's surface again in 2024, and we're not going back this time to just stick a flag in the soil and stay for a couple of days, or they'll be going there to stay for weeks at a time, perhaps months at a time, learning how to survive in the cold vacuum of space. The moon, of course, is in synchronous rotation with the Earth, which means that it rotates at the same rate on its own axis as it does as it rotates around us, or orbits around us. So roughly 28 days, 20 and a half days, I guess. So we always see the same side. This is the side we always see, the near side of the moon. The other side of the moon is not the dark side of the moon. That's a Pink Floyd album. I used to listen to it constantly. But this is actually the far side of the moon, the other side. So we're looking at the near side here, and this is the side that we always see. These large patches that we see are Maria, which is the Greek word for oceans. Back when Galileo was looking at the moon, he thought these were oceans or seas, so they called them Maria. and those are actually large, dark volcanic plains covered with basalt. These plains were formed back during the formation of the moon. After the formation of the moon slowly cooled, but the magma was just underneath the surface of the moon. It didn't have very much of a crust at that time. And the moon went through a period called the heavy bombardment, when large meteors were hitting the moon, and they would break through the moon's crust and bring some of the magma up to the surface. And then these large areas here would be covered with lava, and eventually the lava would cool, of course, and then darken. And from the iron content that was in the lava, they would get this non-reflective type of surface like they have here now. So these large gray patches are not very reflective. It's more like the reflectivity of asphalt, I guess, is about what the moon's surface is. Now, when we see astronauts on the moon and you see these bright patches around them, I mean, the moon is reflective, of course, because of what we see, but that's just because there's so much sunlight hitting the moon that the moon is so bright for us. But it's really not that reflective surface at all. The side that we see here, like I said, is covered with dark volcanic maria that fills the spaces between the ancient highlands and the prominent impact craters. And the moon is the second brightest object in the sky next to the sun. Of course, we talked earlier that Venus is the third brightest object. The surface is actually fairly dark and has a reflection of asphalt. The moon is about 30 times the diameter of the Earth away from us. And it continues to move away from us at the rate of about 4 centimeters per year. We know this because in the days of Apollo, the astronauts that walked on the moon, on the moon's surface, they left behind some mirrors, or reflectors. And today we aim lasers at those mirrors, and we measure the time it takes for a beam of light to strike them and then return back to the Earth. And that tells us the exact distance of the moon. So we know that it's moving away from us at the rate of about 4 centimeters per year. I guess it stands to reason that if we look back at 4 billion years ago, the moon was much, much closer to us when it first formed, and we believe that it would have been about 18 times larger in our sky than we see it today. And that's a little bit about the moon. The moon was first reached by the Soviets in 1959. The U.S. had the only manned missions on the moon to date, with 6 moon landings taking place between 69 and 72. The moon's far side has a crust that's about 50 kilometers thicker than it is on this near side. We believe the moon has an iron-rich core about 250 kilometers in diameter and a fluid outer core that's made primarily of liquid iron. The moon's most prominent feature is actually the giant far side South Pole Aitken Basin, which was formed about 4 billion years ago. It's over 2,240 kilometers in diameter. And it's the largest crater on the moon, and actually the second largest impact crater in the whole solar system. It's 13 kilometers deep. That's unbelievable to think of a basin or a huge crater impact on the moon that's 13 kilometers. Think about 13 kilometers now, how deep that is. And its floor is at the lowest point on the surface of the moon. The dark areas, again, are called maria. And almost all the maria are actually on the near side of the moon, and they cover about 30% of the moon's surface on the near side, compared to about only 2% on the far side of the moon. Lying on top of the moon's crust is a fine powder we call regolith, and it's actually comprised of dust, soil, rock, and other materials, and it's basically disintegrated rock that's caused by continuous bombardment of the moon's surface by meteorites. Like sand on a beach, the moon's surface is continually weathered into smaller and smaller particles. So when we look at the footprints that we can still see from Neil Armstrong and those people that were back in the 1960s and 70s that were on the moon, the only thing that would ever remove those footprints that we believe would be these tiny micrometeorites that continually bombard the moon's surface. And eventually they'll fill in those footprints, and they'll fill in those tire tracks and the other things that we left on the moon. Just looking at some comments here. I see your bear, Paul, now. Haha, Irene says.
You see? I'm not crazy.
Irene says Sheldon and his friends did this one night. They did, Irene. That's right. They pointed a laser beam at the moon, and I remember that episode on that show, The Big Bang Theory, when they pointed a laser beam at the moon. And
it didn't blow up.
Joanne asks, why haven't we returned to the moon with today's technology? And that's a good question, Joanne. um, why haven't we returned? Well, we are going to return in 2024, and that's the difficult part right there. Is you mentioned today's technology, so we'd have to incorporate all of the technology that we have today into a new space. People say, well, why don't we just go back with Apollo 11? You know, we went there in Apollo 11, and they only had a tiny little computer. But that's right, they did. They only had a tiny little computer. But today we have much bigger computers. I mean, we went to the moon with the equivalent power of a dollar store calculator. Um, so today, when we go back to the moon, we're going to be taking a lot more technology with us. So we have to incorporate all that technology into a new spacecraft. So we have to basically design a brand new spacecraft to take us back. So that's one of the reasons that we haven't been back. The other bigger reason, though, really is because there hasn't been the will of the people to go back. We have to remember back in the time when this was all happening, there was a Cold War going on. The Soviet Union and the United States were in a battle, in a race actually to be the first to get to the moon. So in Kennedy's days, they approved $20 billion of 1969 dollars basically to put 250,000 people to work on this project to get the first man to put his footprint on the moon. So it was the will of the country, the U.S., and I guess probably democratic societies anywhere, to try to beat the Russians to the moon. And the Russians were going to be on the moon. Like they would have made it there, I think, if they there's a history there. I read up on it. It's too long to get into right at the moment, but they lost their main man who was pushing for the idea for them to be there. But also the Americans kept making progress on each step that they did. They would go on a mission and they would have to make sure that they met those mission requirements and that they wouldn't proceed to the next part of the mission or the next step until they made sure that that mission was completed. So it was a very systematic approach to going to the moon. But the only reason that we haven't gone back is because the will of the people disappeared. So when you talk about Apollo 13, okay, Apollo 11 was the big one. Yeah, Apollo 12 was the anticlimax, basically, except for the fact that the Apollo 12 rocket got hit by lightning on launch, which is pretty amazing. And they continued on to get onto the moon. But when you get to Apollo 13, people weren't even tuning in to the TV broadcast that they were offering live, at that time. So the will of the people had already started to disappear. And then by the time they got to 15 and 16, they said, okay, well, why are we still going to the moon? We've already been there. We've done that. We've collected rocks. You did all that kind of thing. What's the purpose? So by 17, they canceled the program after 17. Then 18, 19, and 20 were already built. So 18 became, I believe 18 is sitting at NASA's Kennedy Space Center in Florida. 19, I think, is sitting in Houston, and I believe 20 was tore up for scrap. So the only reason that we haven't been back, basically, is the fact that there's no will of the people to go. We spent the last 40 years in low Earth orbit, and it really pisses me off, to put it bluntly. We had to learn how to survive in space. I understand that part, but why we didn't move on to other projects at the time or continue to go to the moon? We probably would have been a lot farther ahead right now in space exploration. But what we do now is we send robots out in our stead to take on these tasks where there's nothing like a human putting their own footprint on another world. There'll be no experience, no robot can experience that practice for sure. So I guess the long story is, or the short story is that it's just the will of the people that haven't taken us back. But apparently they'll be back on the moon by 2024. They are working on the Artemis mission right now. There is a spacecraft that looks similar to Apollo, only larger crewed area for sure. And that's what they'll be doing to return to the moon. Now, Elon Musk, maybe SpaceX, they may even get to the moon beforehand. I know that Elon Musk has a paid customer that is planning on orbiting the moon within the next year or two, I think 2021. And he'll be taking the first paid customer on a trip around the moon. And something he'll probably do it because they're moving so fast. SpaceX are moving ahead so quickly. Look at this satellite project that they have moving on, and they can land. They can bring back their spacecraft, reuse it almost completely now. Even the fairing section, they're reusing that. So the cost for them to launch an object into space is becoming a lot less, and they're making lots of money at it. So private enterprise, I think, will be able to get to the moon and stay there longer than maybe NASA will. But let's hope that that's not the case. So. Tim says we're getting some high altitude clouds here now. Yeah. We're told not to go back. Sorry, go ahead.
Did you see that, the last thing, Chris? What did Tim say?
Tim, getting some high cloud altitudes right now. Tim, I see the bear. No, can't be. No.
Thank you, Tim.
Enjoy the decline
That's
says
because of the high clouds.
Enjoy the decline says we were told not to go back to the moon. That's interesting. We were told not to go back to the moon, and it's probably who told us not to go back to the moon. I'm not sure what that. I'd like to see if that clarified maybe a little bit, but I think that we should have stayed at the moon. We went there, stayed for a few days later on, but we had the technology to stay for longer periods of time, and we could have learned so much more than staying in low Earth orbit, spending 40 years building a space station. Really, all our shuttle really was a transport truck to take pieces to space. So that's just my opinion. We're certainly not expecting anybody to agree with it. But back to where we were. So where are we at for time, guys?
We are 9:03.
Oh my goodness, we didn't get much done, did we?
Well, we're having lots of fun.
Okay. Well, that's. Any other questions about the moon? I'm just looking here to see.
We had enough time.
We bear. Great job navigating us above the moon, huh? Perfect. Thanks, Paul, for that. Nice view of the moon. So don't forget supermoon tomorrow night if you've got a clear sky in your area. I think St. John's going to be clouded out, but we'll have to wait and see. But yeah, supermoon this month and the next 2 months are actually supermoon months. So they'll have the moon within 10% of perigee for the next 2 supermoons. So, Mike, did you want to talk about webcams? Because we did promise, I guess we were going to get into some part of that.
Well, it wasn't like this big in-depth conversation about webcams. What I was going to do is basically show you how you can take a normal everyday webcam and turn it into a guide camera for your telescope.
That'd be perfect.
When you go out to do any type of astrophotography or whatnot. And, guide cameras, when you go to the astronomy stores, aren't cheap. And all they do is pick on a star and guide. Well, webcam could be used just as well. I've gone down to my local Value Village and, pick up this is a Microsoft webcam. I forget what they call them. Just a life cam or something like that. And virtually all you have to do is take your fingers, unscrew the lens, take it completely out. Either buy an adapter like this one. It's basically it's a webcam to 1.25 inch eyepiece adapter that screws directly onto the webcam, just like that. And now you can plug this into your USB port in your laptop or your computer. And PhD software or PhD2 software actually recognizes serial, USB, and long imaging webcams. And one of those 3 will pick it up, and now you basically have yourself a guide camera for pennies as opposed to hundreds of dollars.
Nice.
The other thing you can do if you don't have the fancy adapter that you can purchase these on eBay or wherever, my good old fallback of a 35 millimeter film canister. You glue it on the camera, cut the top off it, and now you have an 1.25 inch adapter that's just hot glued onto a webcam. And now you've got a guide camera made out of an old webcam that I found at Value Village and a 35 millimeter film canister.
Yes, sir.
And this one actually works better than the Microsoft one.
Really?
Someone was asking a question, I think, earlier. Somebody was asking a question earlier about is there a better webcam than others?
Yeah.
Yes. Supposedly Philips puts out a webcam, and the people were using Philips to do some very early deep space imaging because they were light sensitive. The problem was with the drivers for Philips, they won't run on a lot of windows, especially the newer windows. This Microsoft webcam was generic. It basically plugs into any Windows operating system. It picks it up as a generic webcam, and away you go. The Philips ones, you'll have a hard time finding the drivers. They can work with the newer versions of Windows, is what I found. I had 3 of them, and not one of them worked. So be careful, if you're looking to say, okay, Philips is better than Microsoft. I'd stick with the generic Microsoft ones, or any old generic webcam that you can find on the shelf for 99 cents. It's worth the lens out and making an adapter on it, and away you go. And they work really, really good as guide cameras, believe it or not.
Thanks, Mike. That's perfect.
So that's me. I even went quickly one step further. Something, if I can use one as a guide camera and they're light sensitive enough, why can't I make a part sky camera as opposed to an all sky camera? An all sky cam has a 180-degree field of view on the lens, but I found a wide field cam. I stuck in a piece of PVC pipe. My wife had a treat tray, something to put peppermints on, and that makes a good shield over the top for rain or snow or ice. Basically, I shoved a big piece of foam rubber up in the bottom to hold the camera. It all plugs together. I got a piece of Velcro on the bottom of it that holds it to the top of my the observatory trailer, and a USB plug that comes down and plugs in. And now I've got basically using Sharp Cap 2, I've got myself a part sky camera that I can catch meteorites going across the sky with, made out of a simple webcam. So that's your Mike Guyver moment, what you can do with webcams.
Perfect. Thanks, Mike.
Wow.
Always something. Always has an easier way. Save that money.
Always something.
Save enough for that big scope.
That's what it's all about.
That 14-inch Hubble.
Do it cheap.
Hubble. Yes, sir. All right. I'm just going to share. What's that?
I think our clouds are starting to move in a bit.
Yeah, I think so. I'm going to try sharing the screen here if I can. And I'm going to try to share this one, I guess, for the moment. And I just want to bring up a few pictures that people had submitted tonight. So we'll see if you can see them. Thanks for first of all, folks, for bringing in the pictures that you did. And I wanted to let you know that you can bring them up to Sunday Night Astronomy Show at gmail.com. That's the address to bring them up to, or to send them to, and or send them to my Facebook page if you like, Astronomy by the Bay, or add them here somehow. But Sunday Night Astronomy Show, all one word, at gmail.com, and we're happy to offer your photos up here. So let's see if I can get one up here. And this is one that Irene on our call here captured tonight, I guess. You guys still there, are you?
Nice, it looks like you're.
Yeah, okay, good. All right, you're here. All right, you're getting it. So yeah, that's the moon tonight from Irene's point of view. Irene Doyle. Thanks, Irene, for sending that in. And here's a second one that she's got offered as well. So lots of detail there. Again,
Nice.
on a full moon, you can still see a lot of detail. All these Mari are still available. There's a nice big crater here in the center called Copernicus, which is really visible. There's Tycho down here in the corner that she had pointed out, with the 1,500 kilometer rays extending out in all directions. So, and you can still see some area down here where we're not quite full yet, so you can still see some detail right along the edge of the moon here. That's being offered to us as well. So thanks, Irene, for that.
It's terrific.
And here's one coming from Emil, with Emil's capture of Venus.
Nice shot.
Nice phase of Venus there.
Must have better skies than memory street tonight.
Well, that's actually, he's got 2017 down there in the corner, so I guess it wasn't wasn't tonight, but one he had captured in the past, certainly. But nice photo, really nice.
Yeah,
and it's got the really soft kind of view,
Right.
like really kind of a soft hue to Venus, right?
Mm-hmm.
Because of the clouds again of carbon dioxide.
You bet.
You bet.
Oh no!
Sorry.
We almost made it through the show. Almost.
Sorry.
You're not sorry at all.
Uh,
Where's Myrtle?
oh, yeah.
And here's a photo
Yeah.
from Brad Kraft. Brad is in our local club, and this is the morning sky. Brad has
Okay.
Saturn. There's Saturn and
Mars.
there's
Saturn.
Jupiter and Mars all together, lined up like this. Really nice. So
That's
here's our ecliptic in the morning sky, nice and low. So we've got.
Is that from Friday night
I think it was
or Friday morning?
March the 5th. So I guess that's what, a couple of days ago.
Yeah.
Yep.
I actually, on the way home from work, I saw that out the window of the truck. That looked
Oh,
beautiful.
Yes, sir. You were driving at the time, or were you pulled over?
Yeah. No. A little bit of both.
There you go. Oh, I'm no judge. Anyway,
But yeah, they were spaced out almost evenly. It was beautiful.
yeah, really nice there. So now what's going to happen? So Mercury will start to appear in the lower left there. Over the next few days, we're going to start, I guess next week, we're going to start to see Mercury popping up down here in the corner. So we'll have 4 planets lined up in our morning sky. Over the next few weeks, though, what's going to happen is little Mars up here is going to drag. You guys see my mouse there? Or?
Yes.
Okay, so Mars is going to be dragging itself down this way towards Jupiter. And at that time, that'll happen over the next couple of weeks. So then we're going to see the waning crescent moon appear here in the sky. So after third quarter moon, in a couple of weeks' time, we're going to see that moon drifting down here along with it. So we'll have a nice photo opportunity of Jupiter, Mars, and the moon together here, with Saturn just off to the left-hand side. Be able to get them all in a binocular view, probably a wide field telescope. You get them all too in the same field of view, but a perfect opportunity for a photo right here when that pops up. And then Mars is going to continue down to the sky, so we'll get to see Mars and Saturn here very close together. And then Mars will drift off farther down, so then we'll have Mars, Saturn, and Jupiter by 1st of May. So they're still going to be in our morning sky in May, and they're going to be drifting around to our evening sky. So we're going to have Jupiter and Saturn for sure in our southern sky most of the summer long. So they're going to be really nice targets. They're not going to be very high because the ecliptic is low at that time of year, but we are going to have some really nice views of Jupiter and Saturn to offer to outreach people all through the summer for sure. So look forward to some nice views of Saturn and its rings and Jupiter and its moons throughout the summer if you come by the eyepiece and take a look. And we got another photo here from Brad. Brad sent this one in of Venus. I guess it was on the same night, on the 5th.
Oh, beautiful blue sky, hey?
Venus sitting there.
Yeah.
Gorgeous.
Not sure what's sitting up here. I don't know what that is, but I suppose right up in this area here would be Uranus, not very far away. So nice capture there, Brad. Thanks for sharing those.
Yeah, absolutely.
And we got a few here from Robert. Robert Gadet has a few here for us. This is Canis Major. Now, I don't know if I got Robert's notes here still with me or not, but I don't think I do. Robert, sorry, I apologize for not having the notes here with me, but I know you did put them on the email. I don't know if I can find them again or not. Just a second here. Bear with me just for a second, folks. I might be able to get that up. And no, I don't think I can. Anyway, that was a photo of Canis Major from Robert. Maybe I could go over it again next week. And let me get back to my screen. There we go. And then Robert did send in this one of the Rosette Nebula as well, NGC 2244.
Oh, nice.
Really nice
Nice
shot.
cluster right in the middle of that, eh?
Nice what? Sorry?
Nice cluster right in the middle of
Yeah,
that.
right in the middle. Yeah, really nice. Great shot there, Robert. We've got another one here of the Running Man that he sent in to us. Running Man, of course, is sitting in around the Orion Nebula area, so another
Terrific
big,
photo. Yeah.
Yeah, really nice. He's also gave us one of the St. George sunset with his Huawei P20 phone. Nice capture. Beautiful colors there. Really nice.
Yeah. Those are birds in the sky, I'm assuming. I can't really tell from this
Or are they dirt marks on my screen? No.
Yeah.
Yeah, they are. They're birds in the
Dirt
sky.
marks with wings. No,
Yeah,
that's terrific. It's a beautiful photograph.
really
Yeah,
nice. Great capture, Robert.
yeah, absolutely.
And I guess Trudy was out, so we've got a few here from Trudy. I'm not sure if I showed these ones from Trudy Allman before. This was May 5th of 2018 of some aurora.
Beautiful.
Don't know if I showed these ones in the last week or not, but I'm showing them again
No,
anyway.
I didn't see that one.
Yeah, I think these might have been sitting in my mailbox. So a really nice capture there,
Oh, it's beautiful.
the aurora, and we've got another one here as well. Nice spike there,
Oh, wow.
really pretty. Trying to make out what's sitting here, but I can't quite make it out. Anyway, really nice shot. Trudy's got some beautiful skies where she is, so
Yeah.
has a nice shot. And here's some other shots that she captured just this morning. So Paul, maybe you can describe where Split Rock is.
So if you go out towards Garner Settlement, actually, if you just keep going out the Garner Settlement way, so heading out towards St. Martin's, then there's a road that'll take you into Garner Settlement. If you follow along that road, you'll eventually end up down in and around this area here. And we were actually out there, I think about 2 years ago, Trudy and me, and I think Amelia might have been there. And we were photographing some stuff just at night. But she's always told me that there are specific times of the year that sun will come up right in the middle of what they call Split Rock, which is an obvious name. And she got it again. It's just fantastic.
What a
Just
shot, eh?
Beautiful
Amazing.
photograph.
Wow. Yeah, that's a
Wow.
$1 million shot right there. Yeah.
It is. It is indeed.
Amazing. Good capture, Trudy. Really
Wow.
nice. So yeah, you've got to look up the ephemeris to find out exactly when that's going to be in that location, I guess. But apparently, it is possible to look it up, and she's done that. So good for you, Trudy. Your hard work paid off. There's one shot, and
And it's really dark skies there too, Chris. I don't know if you've ever been up there yourself.
I've been out to St. Martin's is beautiful, but I haven't been to Garnet Settlement, but I am going to get out there for sure because that's
it's really dark there. It's quite surprising.
Oh, great shot there. Nice sunrise. Always nice to catch a sunrise, but to catch it like this, that's just superb. And there it is coming up out of Split Rock there now.
Unbelievable.
And there's a third capture she has as it gets up into the clouds. So some really, I mean, it's not all about the stars, is it, Paul?
No, not all about Cygnus, is it?
Our sun's a star, isn't it? Yeah, not about Cygnus.
But it's really interesting to see as she's photographing that as the morning progresses, how as the sun rises, how all those colors change. And it's just such a beautiful thing to watch.
Oh yeah,
She captured it beautifully.
Really nice, really nice. And there's her last shot here, kept this morning. So there it is, sitting there, just kind of kissing the ocean. See that?
Oh, look at that! She's got the different phases coming up. Yeah.
So that's a real cool feature. So that really does show you the atmospheric diffraction. I guess what's happening with the sun coming through the atmosphere here. It almost looks like it's coming right up out of the ocean itself, and it's breaking off, and amazing the reflection.
Fantastic.
Fantastic captures. Really nice. Well done, Trudy. Really well done. So I'll get back to what else do we have? I think that's probably going to be it for tonight, is it, guys?
I think so.
Let's take a look here and see if we got anything else coming up. A single shot, Robert says. So thank you, Robert. Appreciate that. John Boone. Hi, Chris. Did you catch the full moon, or was that tonight? Hi, John. I didn't catch it tonight. I was on the show here. Well, I guess our show started at 8, so we prepare for it a little bit beforehand. Probably a good thing we did because we had some trouble tonight with technical difficulties. But John, the supermoon, quote supermoon, is actually going to be offered tomorrow night. So if you've got clear skies where you are tomorrow night, you should be able to get out and take a look at it. But tonight, when it rose tonight, it was fairly close to the same. I'll try to get this picture out of the way here. Close those out. I think I gotta do this before I hang up on everybody. It wants to do that on me, but it does. There we go. Hey, Mike, you're back. I'll stop sharing. There. Paul's back. I'm back. We're all back. Yeah. So those photos were fantastic. I guess yeah, the moonrise supermoon is really going to be tomorrow night. Um, so if you've got clear skies in your area, the moon locally here at Atlantic time, it should rise around 7:30 or so. So you've got an opportunity tomorrow night, if you do have clear skies, to watch the sun set at about 7:22 and the moon rise at about 7:32. So you've got about 10 minutes time in between to sit and relax and do whatever you do for 10 minutes and take a look to the eastern sky. Look at the west and watch the sun set. Look to the east and watch the sun rise or the moon rise. And how much better can it get, huh? It doesn't get any better than that. That's it. So especially on the full moon nights, you're going to get to see the sun set when the moon rises. So that's what you want to keep an eye out for. The moon, of course, rises about 40 minutes, from 40 minutes to an hour later each night. But see if you can get out and catch that supermoon. And if the supermoon doesn't mean much to you, simply the fact that you're out taking a look at the moon really is quite enjoyable. If you have a pair of binoculars, grab them, bring them along with you, because binoculars really are a nice instrument to check out the moon with. You can see a lot of detail with binoculars. Really, you've got two telescopes, so you're getting a correct view. They're not very heavy. You can get it sitting in a comfortable chair. They're fairly inexpensive to buy. Most sets are pretty well collimated when you pick them up. And you'll get to reveal a lot of detail that you never really thought you could with a pair of binoculars. Of course, they're great in the Milky Way and the Pleiades star cluster and that kind of thing too. But keep an eye out on the moon with them too, because they're always a great target or great object to offer. We've got a few more comments. Just checking here. Nice photos, everybody. Upcoming outreach. Trudy. Upcoming outreach. What have we got for outcome? Oh, we got our Hampton Beginners Workshop coming up. Paul, do you want to carry that away?
Sure. So let me see if I can find my mouse. Where'd it go? There I am. Yeah. So what's happening starting Wednesday night in Hampton at the what they call the Lighthouse Center, which is, if you're familiar with Hampton, it's a little building just right down by the Green Bridge. And we're going to do a 4-week series on introductory to astronomy course. And we're going to cover everything from the night sky, how to navigate it, how to look up and look around and see what's up there. And then we'll cover what you need to take a closer look, telescopes, binoculars, cameras, mounts, that sort of stuff. And then we'll get into a little bit about photography in terms of just nice, something similar to what Trudy and Emil and everybody else was showing there, just some really, really nice, easy photography that you can do and get some great results right away. And then on the 4th week, we're going to be, I think we're just going to play that one by ear, because there might be some surprises that we'll have for that last week. So anyway, so that starts on the 11th and it goes right through till we hit number 4 Wednesday, which is said the first week of April.
And the cost is free.
And it's free. Absolutely.
What else can you get for free? So we were going to do a little talk tonight on some star parties, like what star parties are to us, what they mean to us, and I've had some photos here prepared, but we had some clear sky. So again, when we have the clear sky, we try to offer objects that are live through the eyepiece too, for those who can't get out to see us. So they took precedence tonight because we did have some clear sky. We've only had maybe this is our 4th night of clear sky since we started this program back before Christmas. So we took the opportunity to show you some night sky targets tonight, and I hope you enjoyed that part. Paul there behind him has a solar scope sitting on a stand, so we're going to talk about solar scopes, but we'll save that talk probably for next week. So we've already got half of a show for next week. Some star party talks, some solar scope talks. We didn't get a Rosanna's fun fact this week, but we got some nice music for it next time around. Nice introduction. Thank you, Peter, for all that. We've put all those aside now, so we'll be able to play those when that comes about. But for now, I guess, folks, we're going to call that an evening. We're sorry we're a little bit late coming to you, but we're glad that we were able to bring you a show nonetheless. So the show must go on, as they say, and sometimes we have some difficulty, but that's part of being live. So how many more shows left? Emil's asking. Emil, we're just discussing that ourselves, and we're not really sure what we're going to do yet. We know that we're into daylight savings now. We're losing an extra hour of daylight, and we're gaining about 3 minutes of daylight each day, over and above the fact that we're moved ahead an hour already. So we've talked about some ideas. We've talked about maybe doing some capturing of objects on another evening, like late at night or something like that, and then offering that recorded part up on our Sunday night show. So we could still just offer a live stacking feature, showing it that it's live stacking, but talk about what we did to capture that image. So that might be a possibility. Uh, we're certainly used to the fact of not having clear skies, so we seem to have not run out of topics yet so far. So really, maybe the daylight part isn't really going to bother us much because we're almost like we're inside all the time anyway. So and we don't really want to lose the people that are here with us either. So I mean, we'd like to keep everybody that's been joining on with us interested. We know what can happen with things today. So you drift off for a couple of months and all of a sudden you're never around again. So we don't want that to happen. We want to keep you all around. But I mean, we may end up breaking for the summer months, maybe for July, August, simply because we know people are going to be out enjoying their Sunday evenings and they may not be tuned in to watch us anyway. There's long weekends coming, that kind of thing. We want to be out doing outreach anyway through the summer. We really enjoy that part of it. We'd rather have you come to the eyepiece to look at things directly so we can talk to you one-on-one rather than offer them over the screen like this. So we may end up taking a break for July, August, maybe, and we might just do a show maybe every couple of weeks, something like that at that point. But at this point right now, we're going to continue here for a little while longer. We're going to see how we all make out between the three of us here. We'll make a decision, but we'll keep you posted certainly on what we are doing. And Irene, you're getting lots of comments here tonight. Or Irene says maybe you could do it later, like 9 or 10. Or are you old guys in bed early? Yes, we are, Irene. We are in bed early. We like to get our Wheaties, our pablum into us and our porridge. And
Emil had a suggestion.
Emil, what was the late night astronomy show? No, we can't go there, Emil. Although we might get a whole lot more viewers.
Well, no, hold on now. We are adults.
We are adults.
This is an adult astronomy show.
The adult astronomy show. Yeah, right after never mind. Right after the Sue show. The Sunday night sex show. Yeah. We'll be on right after that. Where'd Mike go? Is he still there?
I think so.
Hello, Mike? Oh, Mike's off air. And there, see, that's what happens when we go live. We see him. We see him, but we can't hear him. I know he's with us. He's with us in spirit.
It works better when you turn on the microphone.
There. Hi, Mike. Welcome back. Another way to use telescopes. Emil, be nice now. We're still live.
Keep the scopes pointed up.
Yeah, this is the family show. The Peeping Tom show. No, we're not going there either. So this is a family program, folks. We want to keep it as a family show. So at that, with all these comments coming in, I think we are going to sign off right about now.
we're getting trouble. We don't.
Yeah, we are. That's right. We're going to be.
Until we start the late night astronomy show.
We're going to be restricted from YouTube here very shortly. We keep up. So thanks, folks, for joining in again. It's always been a pleasure. It's been a great experience for us. We're starting to get a little bit more comfortable, as you might notice now that. We're not worrying too much about the production part of it. We're just having a few laughs and enjoying the fact that we can share what we can with you. So hope we'll continue on with the show here for a while longer yet, and we'd like to see you all back again next week. Please pass it on to your friends and family that we are here. This is the reason why we're bringing this to you is to teach astronomy and to educate and offer what we can. So if you have friends that are maybe interested in it, point them our way. Please consider giving us a little bit of thumbs up there too if you enjoyed the content that we've had so far. If you haven't subscribed, please subscribe to the channel. That always gives us a little bit of a boost for sure. And if there are comments, please just leave them in the comments section. I do go back and check on the comments later on. And if you have suggestions for future shows, please send them on to us as well. We're more than happy to take ideas that we're looking at for future shows. We're always looking for ideas to fill in the time slot. So, and we're happy to do the research ourselves as well because we learn as well when we're doing research on a topic. So with that note, folks, we'd like to say thank you very much. We wish you all a very good week, pleasant viewing. Hopefully that your skies are clear. And as Mike would say to you, Mike, what would you say?
Keep your scopes pointed
up. Good night, folks. Thanks very much. Take care.
Good night.
Night.
See you all again next week.